Hello friends, myself Shivam. Today we are discuss about the topic deadlock in operating system. Definition. What is deadlock? A deadlock is a situation in computing where two or more processes are unable to proceed because each is waiting for the other to release a source. It is effective halts the progress of all involved processing, leading to potential system influences. Importance in system. Understanding deadlocks is crucial in system design and resources management. Deadlock can lead to complete system freezes or significant performance degradation. Effective management of deadlocks ensures system reliability and efficiency. Common scenarios. Common scenarios that lead to deadlocks include multiple processes requiring shared resources, complex resource allocation partners, and system when resource request and release are not coordinated properly. Example include database management system and multi-threaded applications. Conditions mutual exclusion. The condition states that at least one resource must be held in a non-shareable mode, where only one process can use the resource at any given time. If another process requests that resource, it must be delayed. Hold and wait. In this condition, a process holding at least one resource is waiting to acquire additional resources that are currently being held by other processes. This can lead to a situation where resources are effectively held hostage. No preemption. No preemption implies that resources cannot be forcefully taken from a process. If a resource is being used and needed by another process, the latter must wait until the former releases that resources. Circular wait. The circular wait condition occurs when there is a set of process waiting for each other in circular chain. For example, process A waits for a resource held by process B, while process B waits for the resource held by process A. Detection. Deadlock detection algorithms. Deadlock detection algorithms are methods used to identify the occurrence of deadlock in a system. These algorithms monitor the state of resources, allocation, and process status to determine if a deadlock exists. Notable algorithms include the wait die and bound wait schemes, which manage processes priorities to prevent deadlocks. Resources allocation graph. A resources allocation graph detected graph that represent the relationship between processes and resources in a system. It consists of nodes for processes and resources. The detected edge showing resources allocation or request. This graph can be used to determine if a deadlock exists or detecting cycle. System state and transition. Monitoring system status and transition is essential for deadlock detection. By analyzing the state of each process and resources allocated to them, systems can determine potential deadlock. State transition matrices can be implemented to visualize the process and the resources they request or hold. Prevention. Resources allocation strategies include policies of assigning resources that help prevent deadlock strategies such as allocating resources to processing only if they can be fully satisfied or using resources ordering can be effective minimize the chance of deadlock occurrence. Avoiding hold and wait. To wait the hold and wait condition, processes can be required to request all needed resources at once. Instead of holding resources while waiting for additional ones, this policy can considerably reduce the potential for deadlock. Implementing timeouts. Implementing timeouts involves setting a time limit for resources request by processes. If a process cannot acquire the necessary resources within a predefined period, it is forced to release its resources. The approach minimizes the chance of identifying waiting and potential deadlock. Recovery. Process termination. Process termination involves safely terminating one or more processes involved in a deadlock to break the cycle of waiting. While effective, this approach can be lead to data loss, inconsistency, which must be managed through proper logging or recovery mechanism. Resources premium strategies. Resources premium strategies allows the system to forcefully take resources away from the process to allocate them to other priority based require. It involves technicians assigning priorities to process, where higher priority process can preempt resources from lower priority ones during a deadlock. These matter ensure that critical processes can complete their task while dealing with resources connection. Conclusion. In summary, understanding the managing deadlock is crucial for maintaining system performance and reliability by implementing detection, prevention, and recovery strategies. Organization can mitigate the risk associated with deadlock and ensure that ongoing processes operate efficiently. Thank you.